Alright, so it's come to my attention that some of the peeps who touch the materials here don't understand how Phong works. We are fixing that immediately. I'm not going to explain what Phong is, but I am going to explain and demonstrate how to use it. Let's go over the major parameters. I've also got this neutrally gray sphere here to help demonstrate. First off, Phong. This is the most important parameter. Without this, none of the rest matters. This needs a bool, which means 0 or 1, on or off. Setting it to 1 enables Phong. Additionally, make sure that your material has a normal map. By default, the alpha channel of the material's normal map will act as a mask for the Phong. Secondly is phongboost. This multiplies the intensity of the Phong. The documentation says that this requires an integer, so whole numbers only, but actually it can be a float, so decimals are fine too. Next up, the phresnelranges. This is the one that seems scary, but it's really not. It needs a vector 3, which is 3 values for x, y, z. I'm going to explain exactly how this works in a little bit, but for now, let's use the default values, which are 0, 0.5, and 1. Finally, the exponent. The exponent is how broad or tight the highlight is. Think of it as a glossiness level. Low values produce a broad, more matte-looking highlight, whereas high values produce a tighter, more glossy one. This parameter sets the exponent uniformly across the entire material. You can define it as any number from 1 to 150. Alright, so with those 4 parameters, you have the essentials. You did it! Phong is active and functional. Great work. You could get away with just tweaking the boost and exponent values, and chances are nobody would complain. But there's more, so let's tackle that. So the next parameter is phongtint. Generally speaking, the color of your Phong reflections is defined by the color of the light source they're reflecting. But we can tint the reflections to a color of our choosing by feeding this parameter a vector 3. The 3 values represent red, green, and blue. Increase the red value and your reflections get a red tint. So now I've shown you both the exponent and tinting. There's an extra way to do both of these. It's more useful too. That'd be the exponent texture. This is a special texture that lets you define the exponent per pixel instead of across the entire material. This is what you want, because chances are your material isn't actually uniformly glossy the entire way across. So let's get one of those. First off, this conflicts with both the phongexponent and phongtint parameters. Do not use those parameters if you want to get the effect from the exponent texture. If you have either of those defined, get rid of them, otherwise it'll override this. The logic for the exponent texture is the same as the values before. Low values, black, are for broader highlights, whereas higher ones, white, are tighter. Now we can export this as grayscale, and that's perfectly fine. Mission accomplished. But I also mentioned tinting. For that, we're going to use the phongalbedotint parameter. First, let me add a splash of color to this so it's easier to see what's going on. What this does is multiplies the albedo over the Phong reflections, effectively tinting them the color of your albedo. This is really nice for metallic surfaces especially. This is also defined by the exponent texture. The red channel defines the exponent, while the green channel acts as a mask for the albedo tinting. I'm not going to teach you about channel packing, but that's how these work. Notice how the reflection changes color to match the albedo instead of remaining white. This helps it feel less dielectric and more like an anodized metal of some sort. Okay, now let's go back and look at that scary phresnelranges vector. Don't freak out, it's actually super simple. So, faces on a model that could be visible to you can be directly perpendicular to you, say looking straight at a wall, or directly parallel, which is technically impossible to see because you're not a fourth-dimensional superbeing, presumably at least, or any angle between the two. So, the first value of your phresnelranges defines the intensity of the Phong reflections on faces that are directly perpendicular to you. The last value defines the intensity of the reflections on faces that are directly parallel to you. The middle value defines the intensity of the reflections on faces directly in the middle of those two, so when the face normal is angled about 45 degrees away from you. Here, let me demonstrate with this gradient and the default ranges. First number, 0, black. Second number, 0.5, neutral gray. Last number, 1, white. This results in a perfectly linear gradient from black to white. Let's look at the sphere again. I'm also going to black it out a bit so that we can make out the subtleties of the Phong more clearly. Alright, you can already make out what's going on here, but I'll make it even more clear and move the reflection to the edge. On the faces pointing more towards us, the Phong reflections are close to 0 intensity. The more parallel the face, the closer they are to our final value. And then the faces halfway between the two are at about half intensity, our middle value. Everything else is interpolated. But what if this middle value wasn't 0.5? Going back to the gradient, let's say make it 0.25. Notice how the gradient changes. The first half is less intense, and then the second half gets crunched down a lot quicker. Let's try that on the sphere. There you have it. The faces pointing towards us are less intense, then the remainder gets crunched down. Okay, let's reset. Now let's say we don't want the reflections to disappear on the faces that we're looking at. We can bump up that first value just a tad. That's how the Fresnel ranges work. There's no correct values, just experiment to find what works for your model. Finally, I've been using values of 0 to 1, but you can actually use whatever you want. You can even use values above 1 for extra intensity. But if you do that, be careful because it factors into this last thing I'm going to talk about. Alright, here's the bitch. Phongwarp. Phongwarp is... So, phongwarptextures look weird as hell, but they're a bit more simple than you'd think. First of all, phongwarps are directly influenced by your Fresnel ranges, so I'm going to use pretty much the default values here. I'm going to have the first one slightly above 0 so that I can keep a little bit of phong on the faces pointing towards us, just to make it easier to follow. Now, I'm going to create a phongwarptexture. Don't freak out, it's pretty simple. So we've got this. Dirt simple, just a gradient from red to blue. Let's just call the top of the gradient 0, and then the bottom 1. See where this is going? Let's look at our sphere again. Alright, so we've got this more or less linear gradient. Now let's add our phongwarptexture. Yep. The reflection gets tinted by the corresponding part of the phongwarp. And as I said, the Fresnel ranges directly influence this too. Move the middle range up and I can get more of the high-end tint. Move it down, get more low-end. Okay, so with that being understood, hopefully, it's a little more complex than that. I'm not going to get into the technicals of it because I'm what technical artists refer to as kind of an idiot, but let's quickly replace that phongwarp with this DUDV map. Except with one quick change for some extra clarity. Okay, I'm going to let you work out what's going on here because, again, kind of an idiot, but you get the picture. Alright, one last thing to finish up. Earlier I mentioned that you can use Fresnel ranges above 1. If you do this with a phongwarp, what happens is the warp begins to repeat itself after it hits 1. You can do some weird stuff with this. I'll let you sort that out. Anyway, so that's how Phong works. Best of luck.